Now I'm going to tackle about the geometric design, polygons and types of polygons. Geometric design is a fun trend that focuses on the simplistic beauty of mixing certain shapes, lines, and curves together for creative results. You may have seen it incorporated into fish tattoo, designs, abstract, and background, and even jewelry. Jewelry design. The geometric designs are a popular trend that showcases basic shape in creative designs rooted in actual mathematical principles. Geometric designs can be created with a formulaic precision or through experimentation. There's a guide. This is the guide on how to make a, a design using the geometric pattern. No, geometric design is one of the coolest trends going around in the graphic designs. They are created with a simplistic shape after arranging and aesthetically pleasing. Fashion like optical illusion of tribal designs. And these are the example of geometric designs. Use a mixing pattern to create a beautiful result using this geometric pattern. Uh, Also in the tattoo and jewelry designs, they use a pattern to create a beautiful result using those shape. They mix a shape to create a beautiful result, or they mix the shape to create a beautiful result, just like this. Uh, have you noticed what they do to become a creative of the result? And also this is an example of the pattern, geometric stainless glass pattern. There are four effects offered in this collection. Use them for background, flash card, website, and more. They use a different types of, they put colors, or they use different types of shape for the best result. And also there are triangle geometric designs is one of the example of geometric design. Triangle geometric patterns offers 9 beautiful triangular patterns in various files types, perfect or a background for invitation, cards, DIY project, greetings card, logos, kisses, print, design, branding, packaging, poster, wallpaper, blogs, or advertising, and more. Those are all examples of geometric designs. And now let's move on to the polygons and types of polygons. What's polygons? Polygons in geometric, polygon can be defined as a flat or plain two-dimensional closed shape with straight sides. It does not have a curved sides. The word polygons means mini angle from the Greek. Notice that a circle or three-dimensional objects or any shape that include curves and any shape that aren't closed are not polygons. In polygons, there are types of polygons depending on the size and angles. The polygons are classified into different types, namely regular polygons, irregular polygons, convex polygons, and concave polygons. Now let's move on to the regular and irregular polygons. What is regular polygons? Regular polygons have a congruent size and interior angles are equal, while the irregular polygons do not have a congruent size and have a different measure of angles and side length. And this is an example of regular polygons. This is the pentagon. The real polygons, all their angles are equal, all sides are equal. So we put this is the angle in these lines is implies that they are equal. Their angle E is congruent to angle B. Angle B is congruent to angle C. Angle C is congruent to angle D. Then angle D is congruent to angle E. Angle E is congruent to angle F. And that's the angles they have. There are 6 angles in this shape. There are sides of this pentagon. The side EB is congruent to side BC. Side BC is congruent to side CD. Side CD is congruent to side DE. Side DE is congruent to side EF. Side EF is congruent to EF or side EF is congruent to side EF. And also the regular polygons. Irregular polygons have a sides that are not equal to each other and angles that are not equal. They may be a different different sides of length, but they are not equals. The difference of irregular polygons in regular polygons that uh, the regular polygons are opposite to the characteristic of regular polygons. The regular polygons are all equal. Interior angles are equal and all sides are equal, while the regular polygons, they have a sides but they are not equal. Convex and concave polygons. Convex polygons, when every interior angle is less than 180 degrees, shows concave polygons have at least one angle greater than 180 degrees. Now let's move on to the convex and concave polygons. Have you seen this? The concave polygons with a straight line, continuous straight lines within the outside of the shape, while the concave polygons was intersecting in the interior angles that reflects the interior angles. You know that the concave polygon extended polygon. Convex polygon extended polygons, hindi siya pumapasok yung hindi pumapasok yung extension niya within the interior polygons. But the concave polygon is was intersecting doon sa mismo angle niya here, as you notice this. No, as you notice, and another thing that you see that between the concave and concave polygons, concave is there's a curve, while the convex polygons is nothing. And another thing that you can see that angle here is the interior reflect means that it's greater than 180 degrees, while the convex, if you will do the measurement, dapat ang interior angle is greater than 0 but less than 180 degrees Celsius. So now you have an idea about the convex and concave polygon. Let's move on to the different parts of polygons. So you have your parts of polygons, right? E, B, C, D, E. This one is an example of regular polygons. This is the pentagon. And the center of polygons is 0. Center is 0. And the sides of polygons are side EB, side BC, side CD, and side DE, and side EE. So, and another thing that you can remember is the radius from the center up to the vertices. There, the center of the vertices. There's a radius OE, radius OB, radius OC, radius OD, radius OA. Next is the central angle. And central angle, there are a central angle from E from E to center, and here to B. The central angle E O B, and then angle B O C, and angle C O D, and then angle D O A, angle E O E. And that's the different parts of polygons. So now let's move on to the types of polygons. In this one, there are different graphic. There are polygons, triangle, quadrilateral, pentagon, hexagon, heptagon, or septagon, octagon, nonagon, nivagon, decagon, or dodecagon. Ingon, it means we can put this 13 gon or 14 gon. In each graphic have a sides and angles, and also the vertices in diagnosis in the number of triangles. Um, the size of triangle is 3 and angles is 3, vertices is 3 and diagnosis is 3, number of triangle is 1, while quadrilateral have 4 sides, 4 angles, 4 vertices and 3 diagnoses and 2 number of triangles, while the pentagon have 5 sides and 5 angles in 5 vertices, 5 diagonals and 3 number of triangles, while the hexagon is 6 sides, 6 angles, 6 vertices and 9 diagonals and 4 number triangle. Heptagon or septagon had a 7 sides, 7 angles, 7 vertices or 14 diagonals and 5 numbers triangle. In the following graphics, as you can see, this is a formula on how to solve the number kits. And when you calculate this are formula that used to get the solution all this number. That's all.